So listen up. Take headphones out of ears. All right. So we were looking at the PhET simulation because it's a really great way for us to understand atoms. So I'm going to go with symbol actually, because then it actually ties into the periodic table. So what were some of the things you guys observed when you were playing with this? Where did the protons go? In the center. And what charge do protons have? They're positive, because you see how that's showing positive here and that's up there. If we go to the atom version, go charge, mass. Oh, it actually says it up there too. See? Positive charge. All right, so we know the protons are positive. That's the first kind of note that I would make. I would also note that the protons are in the nucleus. I want to turn on the stability. All right. The other thing we notice is where do the electrons go? On the outside bits. And electrons, what charge would they have? They'd be negative, because you see how when we added that electron there, it went to 0 now for the charge. All right? So when we are talking about atoms, we are talking about things that have one proton, or sorry, not one proton. We're talking about things that have an equal number of protons and electrons so that the charges balance out. You see how it says neutral atom? But the moment I take away this electron, it's now become an ion. So an ion is a charged particle. They can be positively charged or negatively charged. All right? We good so far? Okay. Something else that we should hopefully have noted is that when we add another proton in there, do you see how the element changes? So the key for us to decide what element we are dealing with is the number of protons. Because if I keep adding more and more electrons, does my element change? No, it does not. So the protons are the deciding factor when it comes to elements. So if I have 2, I have helium. We can see that over here. If I go up to 3, now I'm at lithium. 4, I'm now at beryllium. So we're going up one step. Do we see that? All right. Something else that I'm hoping you guys will notice is that I shove all these protons in the center. How are they behaving? They are not happy. They are very unstable. So something to keep in mind about our atoms is that protons are positively charged, and we know that like charges repel. So this is not stable as is, and that's why we have these neutrons here. Some things to keep in mind about the neutrons. First off, they are going in the nucleus when we drop it. Do you see how it doesn't change the charge? So that tells me neutrons have no charge. They are important glue to the atoms because it helps us spread apart that positive charge. So that way the positive protons can be next to each other without going crazy. So I'm going to add these guys until it becomes stable. Still unstable. Now it's happy. Are we good with that? Mm-hmm. All right. Next thing to observe is this number over here. So this number at the bottom is the atomic number. It's the smaller of the two numbers. That's referring to the number of protons. Are we okay with that? All right. This number up here is referring to the atomic mass. So what I've done here is I've taken the number of protons and added the number of neutrons together. And that's what making up the mass of the atom. Are we okay with that? Yes? No? Okay. Now, I'm going to add some electrons. We see there's a charge here. So when I add that first electron, we notice that it loses one of those positive charges and becomes positive 3 now. When I look at the mass, though, does the mass change? No. So what that tells me is that electrons are super, super small. They barely contribute anything. So we don't count them in the mass. It's only the protons and the neutrons. So let's add that up. So since I have 4 protons, I need to add 4 electrons, and now we are good. All right, now it's a neutral atom again. All right, questions so far? Or are we okay? All right, something else that I don't know if you guys realized, if I take this electron away, do you see how one from the higher level pops down? So what that tells us is that there's a rule when it comes to how these electrons go into their electron shells, into their clouds. So the rule here is that we need to have 2 in the first shell. We need to have 8 in the second shell. Now, this atom doesn't go big enough to past 8, I don't think. What is that? How many we got there? 1, 2, 3, 4, 5, 6, 7, 8. So we don't go beyond 8 in this model. So just so you guys are aware, when it comes to electron arrangement, the first shell can hold 2. So that gets me up to, if I reset this, gotta move me, reset this. So if I had 2, that's helium. So I basically get to the end of this row, and then I go to this row here, and that's when I'm starting the next shell. So that's 3, 4, 5, 6, 7, 8, and then I start another shell. All right? I think I'm doing that right. So we should have oxygen as our largest one. Let's see. Beryllium, boron, carbon. Actually, sorry, I might be wrong. We might be at hydrogen. Yeah, no, neon makes more sense. All right, just gonna turn on stability. All right, so we should have enough to get up to neon, which I did my math wrong, guys, when I was counting. It's okay, it happens sometimes. Yes, I wanted to go up to 10. That's why. Yes, I did. Okay, so lithium is the first one in the second shell. So that's 1, 2, 3, 4, 5, 6, 7, 8. And then it starts the next column. Isn't that nice? Isn't that cool? So it's so therapeutic to look at the periodic table. All right. The third shell after that, astronomy people, this third shell will hold a maximum of 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then we start the next shell. All right. The next shell we have only has 2, 1, 2, and then we stop here at calcium. Once we get past calcium, it gets a lot more complicated in where the electrons are going to go, so don't worry about it. All right, if you do want to worry about it, that's level 3 chemistry. Are we good with that so far? All right, so those are some things I wanted to point out to you guys. What was I going to say? What else? So electrons are negative, neutrons are neutral charge, protons are positive. Number of protons decides the element. Protons and neutrons are what add up to make our atomic mass. Atomic number is based off the protons. If you are dealing with an element, the electron number is the same as the proton number. So the next thing I want to talk about is, yes, you are not stable. You're still not stable at that. Oh, you need quite a few. All right. So the next thing I want to talk about is stability in the atoms. So this is a neutral atom. Atoms are most stable when they have a full outer shell. They can do this in one of 2 ways. They can either gain or lose electrons. So for lithium's case, you see how it has 1 electron in its outer shell and 2 in its inner shell. So it can either gain 7 more electrons to fill its outer shell, or it can just lose the 1 electron and go down a shell level, and now it's stable. So in lithium's case, it's easier for it to lose an electron, and it forms the lithium ion, which is +1, which is that guy over here. Are we okay with that? All right, if I was looking at a larger atom, say, for example, let's go bigger. Go nitrogen. Let me put some neutrons in there so it doesn't freak out anymore. It's freaking out. There we go. And then, so if I had nitrogen as an atom, it should have 7 electrons. Like that. All right, neutral atom. Not the most stable form, though. So even though the nucleus is stable, the atom itself is not happy in this format. So again, we want to gain or lose electrons in order to be more stable. So in this case, he has 1, 2, 3, 4, 5. So either I lose 5 or I gain 3. Gaining 3 is a lot easier. 1, 2, 3. So when we see, so nitrogen, it's going to like to be the nitrogen ion because then it's got that full shell. And so this is a negative ion here. Are you okay with that so far? Now, the thing I was trying to explain yesterday that was not very well explained was carbon. So let me get some of those protons out. There we go. So you see how I remove 1 proton? I've gone down the periodic table to carbon. So carbon has 4 electrons in its outer shell. So if carbon was to form an ion, it could gain or lose 4. So carbon, on the other hand, is going to do something unique. And in fact, these guys over here can do the same thing, which is covalent bonding. So we'll talk about that in our next kind of chunk of information. So just seeing where we are with our lesson plan. So we've done the PhET building, we've tinkered with the atom, we've done some notes. There's not really any notes to copy down unless you guys want me to write stuff down. Are you guys okay? Yeah, I think it's pretty self-explanatory. And I think you guys got it covered in your notes already. All right, cool. So we have about 10 minutes left. I think that's enough time to start this bit here, which is the PhET of the molecules. So, like I said, I want you guys to go to the playground version, and I want you to see what happens and what you can build chains of. So just do like chains of hydrogen. So right now I'm trying to put a chain of hydrogen together. You see how that's not going to happen. So I can only build chains of 2 hydrogens, and then it stops. So I want you guys to think about that. So we know hydrogen doesn't do it. Let's try oxygen. Let's find some more oxygen. Oh, really? That's not cool. We'll do this guy again. I'm not really sure why they've designed it that way. Anyway, that's 3. And you see how once I get to 4, I lost the name? So that tells me that it's not a molecule at that stage. So have a little play and try to think about the question which is being posed. And that question is, which element is most useful to build stuff? I will also get you the Molly mold so you can look at the holes, because the holes can tell you how many things can bond to it. All right? Cool. I'll leave it at that.